emphasis of this chapter. We've talked all about graphing them and solving them in the last chapter. Now we're just going to be looking at applications. So we'll be taking problems, writing our own equations, and then solving them using all the methods that we were just using in the last piece. So, first question. If I asked you if this quadratic had a maximum or minimum value, how would you? Okay, this is a positive x squared, which means when you graph it, it's opening upward.
Yes.
So if it's going to open upward, it is a minimum. Good. What is the value? All I want here is the minimum y value, the lowest y value. How do we find that? No. No. What's this point called? The vertex. How do you find the vertex? Opposite of b over 2a. Let's do that. That will give you our x value at the vertex. So opposite of negative 2 would be 2 over 2 times 3. So we get 1/3. But that's not our answer. That's the x value. We need the y, so plug it back in. Okay, so 1/3 squared would be 1/9 times 3 is 1/3 minus 2/3 plus 1, and you get 2/3. So the minimum value is 2/3. If I ask just for that one highest or lowest value, it's just the y there. Any questions on that? Let's look at this problem. I want two consecutive integers whose product is 56. Okay. Not the only answer. We're going to use our quadratics to help us solve this. So the very first thing that I would expect you to do is define a variable. So if x is the first number, if they're consecutive, how do you get the second number?
X plus 1.
Right. So x is the first, x plus 1 is the second. What if I said they were consecutive even integers? How much do you add to get to the next even number? What if they're consecutive odd? How far apart are the odd numbers? Still 2. X and x plus 2. Okay. Then I said their product. What does product mean? Multiply. So I am going to multiply these things. Is means equals 56. Alright, so now this is like a problem we had in our quiz yesterday. What would I do? Solve for x. So we have to distribute. So x squared plus x. Subtract over our 56. Equals 0. What two numbers multiply to negative 56 and add to positive 1? Negative 7. Positive 8. Set each one to 0. I give you a word problem, how do I want you to answer it? In a sentence form. So, the numbers are if the first number is 7, the second one is x plus 1, so that would be 8. So the numbers are 7 and 8. Or, if x is negative 8, then the second number is x plus 1, which is negative 7. So you could have positive 7 and positive 8, or negative 7 and negative 8.
What? I'm confused on the last part.
Okay.
Well, because it's so
Here's your first. X is the first number. To get the second number, you do x plus 1. So if the first one is 7, 7 plus 1 is 8. If the first one is negative 8, negative 8 plus 1 is negative 7. Other questions? Okay. You guys all still taking really good notes? These may come in handy at some point in the future.
So like another note.
Alright, let's look at this. Suppose x represents one of two positive numbers whose sum is 33. Part A. Represent the other number in terms of x. So x is the first number. What does sum mean? So if y were the second one, x plus y equals 33. But I don't want two variables. So if I were going to solve for y here, what would you do? Subtract the x over. So y is 33 minus x. You guys agree with that? That's your answer to part A. The other number is 33 minus x. So all I knew is they added up to 33. We can't solve equations with multiple variables in them. So x is the first, 33 minus x is the second. Does everybody see how we got that? B. What are the restrictions on x? I'm asking you, what numbers does x fall between? I told you that x was positive, so it's got to be bigger than 0. And they only add up to 33, so it has to be smaller than 33. Okay.
What if x was negative?
Then we wouldn't have any restrictions. C. Find a function that represents the product of the numbers. So I'm going to make some function. You can call it whatever you want. What does product mean? So the first number is we have x and so x times 33 minus x. Product, you're just multiplying the two things together. Okay. I should have maybe asked these questions in opposite order. I want to find the maximum product. So you have a quadratic here, right? If you wanted, you could distribute that x, and you have 33x minus x squared. Or if you wanted, you could write that as negative x squared plus 33x. What do you know about that quadratic? It's got a maximum. It's a graph that's going to open down. So I want to find that maximum. How do we find a maximum?
The x equals
Opposite of b over 2a. It's the vertex. So my b is 33. A is negative 1. And what do you get?
16.5.
16.5. It never said that they had to be integers. So decimals are allowed. I just wanted two numbers. Okay. What else should should I do? Plug it back in. So if you can put it in here, you can put it in here, it doesn't matter. What do we get? We're at 272.25. So we have to answer the question. So the numbers are 16.5 and the second number was 33 minus x. What's 33 minus 16.5? The maximum product is 272.25. How are you feeling about these overall so far? Need some more practice probably. Okay, let's look at the next problem. This one's a little bit different. So we have a piece of machinery. Makes rectangular sheets of metal such that the length is 3 times the width. Let's stop right there. I've got a rectangular piece of metal, so what should I draw?
A rectangle.
Rectangle. The length is 3 times the width, so what should we label our sides? X and 3x. Okay, that's defining our variables there. Equal size squares measuring 5 inches on a side can be cut from the corners so the resulting piece can be folded into a box. You guys know what that means? So I'm going to take a piece of paper and I'm going to come in and I'm not measuring, so I'm just randomly cutting here, but we're going to pretend I measured those out. And you're going to cut a square from each side, from each corner. And if I had measured so that these were even remotely close to the same, you get something like this, and then you can fold, and if those squares had all been the same size, then you fold it up and you've got a box. Okay, does that make sense? So we are going to be forming a box. I'm going to draw a box. Okay, there's my box. We need to figure out what the dimensions are on that. So if you think about this rectangle that you had, this side was x, this side was 3x. You came in and cut off these squares. The squares, how big were they? Okay, so I took off 5 inches here and 5 inches here. So how much did I remove altogether from that side? 10. So this side is now x minus 10. Okay, my length was 3x, but I took 5 off this end and 5 off this end. So I took 10 off altogether. So it is 3x minus 10. the height of the box is the same as the size of the square I cut out. You guys agree with that? This is a 5 by 5, so when I fold it up, my box is 5 inches tall. So I have the dimensions on my box. Alright, take a second and make sure you know where I got that. Next thing, talking about volume. Do you know how to find volume? Volume is length times width times height. So I have to multiply these three things together and my volume will be 1435. So 1435 equals 5 times x minus 10 times 3x minus 10. Okay. Let's solve this. One thing we could do, if we want to make our numbers smaller, let's just divide by 5 on both sides. So this will give me 287 equals, and then I have to FOIL this out. I kind of divided by 5 and FOILed at the same time. Okay, set it equal to 0, it's a quadratic. Alright, we have lots of methods for solving quadratics. What can I try now? Quadratic formula? You can try box method. I think it works, but we're going to have some bigger numbers, or you can do quadratic formula, completing a square, any of those options. You guys okay with going to the quadratic formula? Okay. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I get the square root of 3844. That is a perfect square, I believe. That gives us 62. Okay, so now to solve. 40 plus 62 would be 102. Divided by 6 is 17. 40 minus 62 is negative 22 divided by 6. It doesn't really come out very nice, so I'm just going to put negative 11 thirds. Alright, so we drew our pictures, labeled our variables, then just solved a quadratic. Not the prettiest quadratic we've ever solved, but not all that ugly either. We were able to do the square root of it. Now, we need to answer the question. We were originally asked what?
What are the dimensions of the middle piece?
Okay.
What are the restrictions?
So, can x be any number in the world?
It can't be.
It can't be negative. It's the length of a piece of metal.
So it's 0.
So, the smallest x can be, let's talk about these restrictions.
So it's 0.
Can it be 0 though? Because remember, I'm going to come in and I'm going to take 10 off of that altogether. So the absolute smallest it could be is 10. Now, would you ever really make it equal exactly 10 and then cut 10 off? No, so really it needs to be a little bit bigger than 10. Let's just say x is greater than 10. Is there any maximum on how big it can be? No, so we could just write x is greater than 10 there for our restriction. As long as it's bigger than 10, you'll be able to come in and cut your 5 off each end. But there was no actual cap on how big that metal could be. So I know my negative answer doesn't work. So the metal was 17 inches, centimeters. What was my unit here?
17
Inches.
inches, yeah.
By the other side was 3x, so 3 times 17, 51 inches. Alright. That one definitely had a lot more involved.
Is that what we're doing in Math Excel? Is that all it's on Math Excel?
These types of problems? I mean, like all of the ones we've done so far. Alright, any questions on that? Let's I want to do one last problem, then I'll stop today. So, now I'm still talking about the same scenario, but my machine has been altered. So the length is twice the width. So what am I going to label my rectangle? And the squares cut from the corners are 10 centimeters on a side. So when I do my box, so what's this side going to be? X minus 20, because you cut 10 off each end. This one would be? And how tall did you say it was? 10.
Wait, how'd you get to it? Oh.
Because it was twice the Alright, so the volume is 7,500. So to get volume, you multiply all of these. Okay, I'm going to divide by 10. I get 750 equals, if I go ahead and FOIL that out, 2x squared minus 60x plus 400. Then what? Notice anything about these? Anything I can do to get my numbers smaller on this one? Okay. So that wasn't necessary. You could have just gone quadratic formula. Let's see if we can factor this one. Multiply negative 175, add to 30. Except we'll do negative 35 and positive 5. Okay. Set each one to 0, so we get x to be what?
35.
Are both of those possible answers? No, can't have a negative. The question was to find the dimensions of the box this time. So the box is, if I plug a 35 in, 35 minus 20 is 15 centimeters. Okay, 2 times 35 would be
15.
70, 50 centimeters, and 10 centimeters.
Wait, it's 50?
Yeah, if you plug in 35 times 2 is 70.
I was thinking 15. I guess I was
Oh.
going into 15.
The answer we got